Hi, ladies and gentlemen, maths and physics students, teachers and colleagues, wherever you are watching me, I want to say you're welcome. And I want to specially thank you for taking me from 0 to 5K. And that is a very special thing for me. I can't do it without you. And today I'm going to teach you what WAEC 2024 Physics Practical is all about. Please, you need to stick to the end of this video because every detail I'm going to give you is going to be very vital. My idea is that at the end of this WAEC, you score 25/25 in this experiment. Are you ready? Let's get started. Please don't be scared about electricity. It's a very simple and interesting concept. Though I want you to know this, nobody knows it all. If I know everything about electricity, I won't be here talking to you. Maybe I'll be building my own power plants. But what I want us to do is this. This is the list of apparatus WAEC has given to us. I'm going to zoom in for you to see. I won't be wasting my time reading them one after the other. But I'm going to be showing you what they are and how everything here was used in this diagram to show you how the experiment is going to be. Now look at this. The first thing you are seeing there from A to C is this nigger here. This is the Wisdom Bridge. Yes, Wisdom Bridge. No, Metre Bridge actually, but Metre Bridge and Wisdom Bridge are twin concepts because they are doing the same thing. The idea is that in every Metre Bridge, there is a gap in the right-hand side and there is a gap in the left-hand side. And then after that, there is a length 100 meters from 0 to 100. And there is a wire on the length which measures the length of the wire. So that is it. And then at the center of between the left gap and the right gap, there is something at the center. That is where the galvanometer must enter. All right. Then that is what I mean by from A to C. There is this guy here. This symbol is for rheostat. Now, few videos are posted. Some people are saying that there may not be need for rheostat. Young man or your sister, I am not WAEC, I'm not a professor of WAEC who is setting the question. What I'm doing is everything they gave us to use to do experiment, I'm going to use it. By the way, who tells you that you don't need rheostat? Rheostat's job is to divide the voltage in a circuit or to control current. So if the current is showing me full scale deflection, that's something I mean by full scale deflection. When this particular galvanometer hits more than minus 30 or hit more than plus 30, you know that the current is overboard. It's giving you a full scale deflection. What do? You can use the rheostat to control the quantity of current or charge flowing in the circuit in order to bring it to a concise value or number or magnitude. That is the job of a rheostat. Fine, if WAEC refuse to bring it, who am I to question them? If they want to put it, who am I to question them? So please, let's have a pure heart while we are doing these things. Nobody knows this all. Even the people that brought this, there are some mistakes they made which was corrected after years. That is science for you. Nobody has the final say on this. It is always improving and changing from year to year. But what we are going to do, everything I'm going to explain to you is based on the principle of physics. All right, that is the job of the rheostat. This is the battery. This is the key, the switch. Now, this is a resistor they gave us, a standard resistor. Let me show you. This is the battery I am using, and this is the standard resistor. 1 ohm. It is written 1 ohm. But WAEC said we should record it R sub X. Then from D to L is a wire. Now, remember they told us to use 2 resistance wires of different materials, 100 cm long. So these are from D to L is where I'm going to use these wires. The first I'm going to use it for copper wire, and another one I'm going to use it with another wire. The one I can find is constant tan wire. But remember, where you're putting your tie your own wire from zero end is at D. D is your zero. While you extend it, use another meter rule to extend from that place until you measure 80. They say measure 90, 80, 70, and 60. So that is where you start. If you make mistake and put the zero end here, you are having problem because this end is for 100. So it's very careful with that. And that is why they said other necessary materials, because remember, you need a meter rule for this experiment. That is one of the necessary material you need. So meter rule is very important. And so after that, you set up the experiment this way. Then you are provided with this. Everything they said, I'm not going to read them. We are going to do the first one with with P. Because in this question, we are having P and Q. These are two different wires. So I'm doing it for P with maybe a copper wire first. After that, I will repeat the experiment with another wire, which is Q. Maybe I can call that one the Constantine wire. It's going to be very interesting, I assure you. Don't worry. Then there is something I want to explain concerning this value. Okay, now, from this experiment, your major concern should be this zero end to this place is going to be your L. And remember that according to the meter bridge, this particular jockey, this is your jockey. You will use this jockey to find a balance point. And the balance point of this jockey will be when the galvanometer is coming back to zero. So when you use this jockey to be testing on different levels, it will be going this way and going this way. Then time will come when this jockey will make the galvanometer to be at zero end. That is the main key. Once you get that zero end, something happens. Because remember, when the current from here starts flowing, then when they reach this junction, the current will divide, because there is a junction according to Kirchhoff's principle. There will be current flowing in this direction, then there will be another current flowing in this direction. Now, because this galvanometer is zero right now, then D and B will be the same potential. They will have zero potential. They will have zero potential between D and B. Now, but remember that potential difference is always targeted 2 points. Between this D and B, there was a potential difference, but because the galvanometer is recording zero, the potential between D and B becomes zero. In that case, the same current flows from here out, but another current flows all this one now. But then, when that zero potential is recorded, then Rx and this resistance, we are going to be in parallel. Therefore, the same thing, this particular D to L is going to be the same in parallel with B to C. So at that point, we can conclude by saying that the resistance between D and L, let me call it R1, for P, for wire P, I'm going to say that R1 all over Rx is equal to LP over LX is equal to LP over LX. So at this point, I can make R1 the subject formula. We say that R1 is equal to LP all over LX all multiplied by Rx. That is where this equation came from. Look at this equation. So our intention is to be finding R1. Remember, R1 will be changing. We'll have 90 cm. We'll use this wire, put here, then measure 90 cm, and then close the key. Do it for 80, do it for 70, and do it for 60. After that, we drop this wire, bring another wire, then bring another wire, another different kind of wire. Also place it here, measure 90, 80, 70, and 60. On each of them, we record this. We also record the length, Lx. Remember your length, Lx should be from 0 to wherever the joke is going to be your Lx. Then how do you get LP? You say 100 minus Lx is going to give you LP. Now, these are the things we are going to do in the experiment. And when we are using a different wire, this from D to L, we are going to call it R2. And a same experiment is going to be repeated. Now, after that, we are going to plot a graph of R1 on the vertical, no, R2 on the vertical and R1 on the horizontal. Then, in the next video, I'm going to show you a trick how to manipulate these values. But if you are ready, let's go to the lab to carry out the experiment. Okay, we are back again, and if you look at all, these are all the apparatus, one after the other. You can see them. I'm going to use this to assemble the experiment. Oh, this is ammeter. Then, and this is the galvanometer. And this is the rheostat I'm using. This is the rheostat. In connecting the rheostat, I am starting here, entering here, and then I will stop here. Come. I will stop at this point. You see that? All right. So now this is my meter rule. This is the gap I was explaining, where I'm going to put my 1 ohm meter, 1 ohm resistor. If you look at this place now, you see 0 end. I was explaining, very important. One side is 0. Then if I'm starting here, then that means I'll be moving towards this length. This is the wire of the meter bridge. So that is how it is. Then look at that gap. If you look at this opening, it is the place where I'm going to put my galvanometer, one leg, while this other one will be used to be making on the meter room. So this is another gap. What will happen in this gap is that I am going to call this place my D, where I'm going to use this wire. I hope you're seeing this wire. I'll use this wire and put here, then measure to 100 and connect the other one at this part. So this is also the other gap, the second gap I am talking about. So these are the experiment, and this, remember they said other necessary materials. So I'm using a meter rule to help me measure the length of the wire. Now let's go to the work. Okay. All right, so this is how the setup is going to be. This is my 0 end. Yeah, I'm the 0 end. That's 0 end. Yes. So this is my 0 end. So I'm going to put my battery there. Let's go. After this battery, the battery is going next to the key. So this is my key. So this is my key. From the key, I will go to Rheostat. So I've gotten my battery, my key, my Rheostat. Then the Rheostat will go back to Then my Rheostat will go back to the 100 length of the meter bridge. So I started from 0 end all the way to 100. So this is the first part. Okay. Now, since this is my 0 end, I'm going to put my ROX here, which is my 1 ohm meter, my 1 ohm resistor. So I put 1 here at my left hand gap. So this is my resistor right now. So I will go back to the 100. Let's keep moving. At this level, this is the middle of the This is the middle of the galvanometer where I'm going to connect my galvanometer. I mean, of my meter bridge where I'm going to connect my galvanometer. Now, these two parts of the galvanometer. Why are you doing it? Is it shaking?
No.
Now, there are two positive and negative. So one, we go to the jockey. This is my jockey. Is it full now? This is my jockey. So one end, you enter here, and the other length of my jockey is what I'm going to use to be moving on the wire. All right, so I will connect this wire to this part of the meter bridge. So don't worry, it won't shock you. All right, so this is my jockey wire. I will be making points. 1, 2, then I'll be making on 8. So I can slide, but provided I'm not slicing with power, I'll just be moving around it. Let's test to see what will happen. Why? After the galvanometer is connected, the next thing is I will come to this gap. Is where I'm going to use my wire. This wire. So now, since this side is the zero end, this is the 100 end. So 0 end, I will start with the 0 end. I will connect my wire there at the 0 end. I'm using this wire first. Then later I will use the other wire, copper wire. So I'm locking it to avoid fluctuation. So I'm locking this here. So the other full wire, zoom all of them. The other full wire, the other one will go here, but that will be after I must have measured the length. All right, I'm sure you get it right now. Okay, let's test if it will work. Let's go to the key. Show me the key. I'm going to close the key right now. Let's see what happened to the galvanometer. Bring it. Let's see what happened to the galvanometer. Why I am making my point. Okay? Not yet. We'll find why it's not showing. Let's go to the battery and touch the battery. Maybe the wire was not well connected. Let's go back and test. Close first. All right, so after the setup is made, I want to be using my jockey to be going through on the meter rule of the meter bridge to see what this will be happening, what will be happening to the galvanometer. So if I place here, that is when I close my key, I place here. You see that? I place here. So let me show you the job of the, now let me show you the job, for those of you doubting me, doubting the job of rheostat, let me show you the job of rheostat. This is my rheostat. You see the level I put the rheostat. Now see what will happen when I'm using my jockey. You see? See, it's coming close, see? Nothing is happening at this level. When it comes here, it's changing, see? So I'm going to the 100 level, see? 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 See what's happening here. This is what's happening here. This is what is happening. See what is happening. See what is happening. That is because I have not connected the wire. Wait, it's still showing now.
Yes.
But this has it clean. Sometimes plug-in AC.
Come measure it out. Let's talk on
Okay, so that is even when I didn't connect this wire. I've not connected it. Now, according to the question, let me open my battery to help so that my battery will not be. Now I'm going to measure. I'm going to measure this ruler, following my meter rule. Now, the meter rule is 0 here. Show me here. Meter rule is 0 at this level. I'm going to measure this wire. There's wire here, as you can see. So the wire, I'm going to measure to 90. Come and show me 90. This is 90 of the meter rule. It's not showing. This is the 90 of the meter rule. So I'm going to use that place. I'm going to stop it there. Let's go back. Use it to put on the gap of the right hand side. Come close. So this is the other gap. I have to put it. Let me lock it so that it will hold that 90 cm tight. All right. Let's go back to the jockey. Let me close my key. As I close the key right now, I'll use my jockey to find a balance point. Nothing is happening. This one, at this point, something is happening there. So because I have already controlled my current, let me shift this to the end and see what will happen. Have you seen it? This is full scale deflection. That's bad. I need this to come out so that it will not be giving me that full scale deflection. You see, it will just be moving. You see that now? I have controlled the current. So let me look for zero end right now. So you see, these ones are high. It's not 0 end. So wherever the galvanometer stops at 0, not there. Good. At this point right now, I have my 0 end. And my 0 end is at my 0 end, you can see it there. I'm going to say is 73. My 0 end is at 73. So I'm going to record 73. So we have done our first recording. So in this first recording, this is my L, the length I'm going to be varying, which is this wire, the wire of this gap. So I'm going to be varying it. Then the next one now is LX. LS means wherever the jockey stops from the 0 end, while 100 minus whatever I have here. Whatever I have from LX, 100 minus this, you give me this one. So how do I get my R1? I will now have that LX, which is 27 over, no, LP, which is 27, divide by 73 times RS. RS is just 1. Whatever you have, you record in this. We are going to repeat this for 1, 2, 3, 4, maybe 5. And that's what we are going to be doing on this section. So let's start. The first thing I'm going to do is to loosen this wire. Then we measured 80 cm. So I'm going to lose this wire and measure 80 cm. From 0 end, go to 0 end. From this 0 end, have you seen it? Now follow me to reach 80. Until I reach 80, I come fast. See 80 here. Okay? That's it. See 80 here. So I will stop here and pick it there. Then come back here. I will tie it from that point. I will now tie it here. I will close, lock it up so that it will be tight to avoid mistake. All right, so this is the wire connected. All right, so I will use my jockey. I will close my key. Let me show me to close it. I'll close my key. My rheostat will still be at the same level. Now let's look at the galvanometer. Let's find the balance point. You see the galvanometer is turning. I'm coming close somewhere here.
Don't need image again. Why did I say 73? Okay. Because at this point, right? Oh. It's out, right? Let me come here. Is their point, right? And this is 62. 62.00. We'll do the other recording. Let's do 70 and then do the rest. That something happened. The wire are not joined. So from zero end again, come to 70 here. 70 here. I am picking it there. So click 70, show me. Holding it there. One more problem. I just found out right now. You are doing these things, you are discovering things. You don't allow these two wires to join. Once they join, once these two wires join, you have issue. Okay, let's look for let me close my key. I'll close my key. Let me look for the new balance point and see whether it will increase or reduce. Let's start from this side. You see, it's out, right? I'm not, some of you will say, why are you sliding? I'm not sliding, I'm just gradually moving it along. Okay, let's keep going. It's out, right? So it's somewhere here. Right? And this is 58.5. 58.5. So at 58.50. So I will do the rest. And then I'm going to record whatever they are here and find these values. Remember, to get this value, say 100 minus 62. I'll write it. 100 minus 58.5, I'll write it. Then use this one to find this value of his. All right, let's go to another wire, copper wire. Let's remove this wire and replace it with another wire. All right, the assignment of this one is gone. So I'm using another wire, copper wire. And this is my zero end. I'm tightening it. All right, so let me measure. Let me measure and see what will happen. So this one now is going to be Q. This one is for P because there are two wires for Q. So I'm going to have LCM, LXP, I'll call it like that way. Then LQ in CM as well. Then R2, what I'm looking for in ohm. All right, let's measure. From 0 end, okay. From 0 end now, let's get to 90. Good. 90 somewhere here. So, hold on. I will pick it there at 90. Then I will join it here. So I will lock it. Now, let's make sure the wires don't touch, even though they're very tiny. It's hard to see, but they won't touch. Let's go back to the jockey.
I have not look.
Let me close my battery. Then I have look for this. Okay, see, started reacting. Let's look for the balance point. Out, in. All right. At that point, that is 71.8. 71.8. So this at 90.00, 71.80 for LP. I will say 100 minus LXP, whatever I have, I'll write here. Then do this R2 is equal to LP over LXP, all multiplied by RX. Remember that RX is just 1 ohm. So this is what I'm going to do. I will continue this experiment for more other values. The next thing I'm going to do is to show you how to plot graph, and I'm going to do that video in another part. Thank you very much. But remember not to leave this channel without subscribing. Share this video to your friends, subscribe and comment. Thank you and God bless you.